Hello children, this is your physics teacher Sharma and I welcome you all to today's class. In the previous class, we have discussed the introduction to the topic sources of energy, wherein we have learned when we call a source of energy as a good source of energy. If you can recollect, any source of energy which is easily accessible, easy to transport and store, economical and having high calorific value, that means it gives more amount of energy per unit volume, we consider that as a very good source of energy. Now coming to the second part of the lesson, conventional sources of energy. Sources of energy which are being used from a very long time are called conventional sources of energy. These are also called traditional methods. Okay, and amongst those are fossil fuels, biomass and wind energy. What are fossil fuels? Fossils are nothing but the dead remnants of past life. Imagine there is a valley located between two mountains or two hills, and had there been a landslide because of the soil being loose or heavy downpour or a torrential downpour of rainfall, then all the trees, shrubs, grass, everything whichever is there along the slopes of the mountain or the hill would be reaching to the valley. And that is where the soil covers all the flora and fauna which is there in that valley point, and it gets compressed. From above, there is a very high amount of pressure that is acting because of the soil accumulated at the bottom. And from beneath, we are having a very hot mantle which is exerting pressure. So because of this carbohydrate present in plants and animals would decompose, and also due to the action of bacteria and other small microorganisms, okay, it would be decomposing to give you oxygen, nitrogen, carbon, okay, and hydrogen. Nitrogen, oxygen and hydrogen being gases, they escape out. Nitrogen would be doing its part of nitrogen cycle anyways. The only thing that is left out will be carbon, a black color hard powder which later becomes into a kind of stone, a very dense heavy stone kind of material, carbon. That carbon is a fossil fuel. If the same process is happening underwater or under the seabed, then that results in the formation of crude oil which is extracted in the form of petroleum. That petroleum, upon refining, it gives us diesel, petrol, kerosene, naphtha and many other products including coal tar. Now there will be a layer between the surface of the petroleum and the lower surface of the seabed which is filled with air, and that is where we get natural gas. So these all are fossil fuels. Okay. Now coming to biomass. This name itself suggests bio means life, mass. So all the waste materials of plants and animals, they are kept in a container. Okay, the container is closed, and we will allow that to break into its constituent elements either naturally or by adding some chemicals. Now, onion peels, rotten vegetables, the food which is left out, cow dung and other waste products, these all, when acted upon by enzymes and microorganisms, they will give us a gas which is rich in butane, a hydrocarbon, and that is used for cooking. So this is the second conventional source of energy. Now coming to the third one, wind energy. Nobody is a stranger to this form of energy. We have been seeing this wind energy since our childhood. Okay, we may not have seen the practical working part of this, but we do know what wind energy is. We have a propeller, okay, which is connected to a huge windmill that has a fan-like construction, and that picture is given in your textbook, you can see. So whenever that is rotating, it is actually rotating the shaft of a generator which produces electricity. Okay. The ultimate aim of us is to produce a form of energy which is versatile. Versatile means something which can be used in more than one way. Okay. And the most versatile form of energy is electrical energy. So what we do, we use these fossil fuels or wind energy to produce electricity. And this electricity is produced in power plants. Now, to discuss about these power plants, we should know the basic principle. Every power plant will be having a generator. And if the shaft of the generator is rotated, automatically electricity is produced. Okay. We are employing different methods of producing steam to make the generator shaft rotate. So let us first start with a thermal power plant. In case of thermal power plant, what we do? We actually take any fossil fuel like coal, petroleum, diesel, and we burn it. Actually, coal is made into a fine powder even before it could be burnt, so that the burning process is more effective. Suppose I take a piece of coal and I burn it. The outer layer is burnt and the inner surface, inner layer, the inner part, the core of the coal piece may not burn completely, which results in incomplete combustion and loss of energy, loss of fuel as well. So what they do, they make this coal into a fine powder and then they burn it. Upon burning, coal, which is a substance which is having more amount of calorific value, produces enormous amount of heat. With the help of that heat, they boil water and they produce steam. That steam is fed to a steam engine which will rotate the shaft of the generator. So again, shaft generator being rotated produces electricity. It is something which we already know. So in a thermal power plant, what are we doing? We are using a fossil fuel. We are burning it to produce heat. That heat is used to produce steam. That steam is used or it is fed to a steam engine, and that steam engine converts this heat energy into mechanical energy and thereby rotates the shaft of the generator. Now, coming to the other form of other power plant, say hydroelectric project. In that, what is happening? Here, we allow the water to run from a great height. If there is a perennial river, if not perennial also normal river, we can construct a dam. When we construct the dam, the water gets accumulated and that water can be used for irrigation purposes to bring a lot of land into under agriculture, and also the level of water is used to run down the water from a great height. If the water is at a great height, we allow that to run down, and when it is coming down, it will fall through the turbine. Turbine, it may be a new word, but let me tell you, it is just like a fan. You might have noticed when we are carrying a fan, you might have seen, like if anybody is carrying a table fan on their motorcycle, you will see it rotates. It is because the wind which is blowing from the opposite direction is making the wings of the fan rotate. In the same way, turbine also is nothing but like a fan. When water is passing through that, the turbine rotates. That rotating turbine is connected to the shaft of the generator, and the generator shaft rotates, electricity is produced. The other form or the other industry or a place where we can produce electricity is nuclear power plant. In case of nuclear power plant, what we are actually doing? We are using radioactive substances like uranium, thorium, plutonium. Okay. These radioactive substances, when struck by a fast moving particle, they give huge amount of energy. Okay, they break into their constituent small nuclei and they give huge amount of energy. With that energy, again the process is same. We boil the water, produce steam, feed the steam to a steam engine. The steam engine converts this heat energy into mechanical energy to rotate the shaft of the generator. Okay, so In this way, what are we doing? We are using fossil fuels, biomass and wind energy to produce electricity. Okay, so that is all for today's class. In the next class when we meet, we'll be discussing about the next topic, that is alternative sources of energy. Until then, have a nice time. Bye bye.